In previous class, we discussed about what are the different faults occurred in HVDC system. So, what are the different faults? Normally, that is arc back, arc through, misfire, and the commutation failure and short circuits are the main important faults in converter station in both rectifiers as well as inverter sides. So now we discussed about nature and types of faults. So what are the types of faults? Normally faults in AC faults at rectifier end, AC faults at inverter end, DC line cable faults, converter station faults. These are the normally faults. Normally faults occurs in both AC as well as DC sides. So in AC system as well as DC system in HVDC, there is a converter stations. Definitely there is a more number of faults. So normally main problem in HVDC system is a commutation failures. That is a frequently occurred in converter stations. So please see the types of faults. The first one is converter and internal faults. So occurrence is very rare. So fault current is 10 per unit. Protection is valves are rated for small duration of fault occurrence. Next one is the second type of fault is DC line faults. This occurrence is very frequently occurs. DC line faults. Fault current is 2 to 3 per units. So protection is force retardation firing angle. Finally is a commutation failure, very frequent. Fault current is 1.5 to 2.5 per units. This is a single self-clearing multiple beta control and VDCOL, voltage dependent controls. So these are the very frequent faults occurs in system in HVDC system. So the fault current also mentioned in converter and internal faults is 10 per unit. DC line faults are 2 to 3 per unit. Commutation failures are 1.5 to 2.5 per units. DC line faults and commutation failures are the very frequent in HVDC system. So in order to whenever the occurrence of faults, we need a lot of switchgear equipments for protection of system. Normally in AC side, we know the switchgear equipments are the circuit breakers and also relays. So the purpose of circuit breaker is whenever the fault occurs, the relay senses the faults. The circuit breaker will trip that circuit breaker that causes entire section will be not attached to the main section that causes we protect the equipment. Circuit breaker breaks the circuit whenever the fault occurs. So some self clear faults also there, some non self clearing faults also there. So very severe faults are non self clearing faults. For that protection we need a lot of equipments. So in HVDC system, mainly there is a over voltage protection needed, over current protection in needed. So over current protection means main features of converter protection is that it is possible to clear faults by fast control action. So less than 20 milliseconds. Differential protection is employed because of its fast detection and selectivity. Overcurrent protection is used as a backup. The level of overcurrent required to trip to trip must be higher than the valve group differential protection. Pole differential protection is used to detect ground faults. So the normally overcurrents are occurred. What is the cause for overcurrent occurrence? So overcurrent occurs because of the short circuit faults. Whenever the short circuit faults in a system, there is a overcurrent flows in a circuit. So the overcurrent can be avoided by using the differential protection we frequently used. So that is a pole differential protection. Please observe the overcurrent protection in HVDC system. So please see the circuit breaker. This is a OCP overcurrent protection. So this is a VGP valve group protection. This is a PDP pole differential protection. Normally the overcurrent is occurred in both sides. In both sides. In a circuit both sides the overcurrent will be occurrence. So normally in circuit breaker any fault occurs, the circuit breaker will be trip out, that will be deactivate in total circuits. So in similar manner the overcurrent protection also similar manner that will protect the circuit. So the valve group protection, for every valve there is a protection. So there is need because the in valve group there is more voltage in conduction period or more current in conduction period that causes damage the entire valve. In order to protect that one, we using valve group protection. So already I told that the overcurrent occurrence because of the short circuits. So in previous section they clearly mentioned main features of converter protection is that it is possible to clear faults by fast control action. So mainly we using the differential protection because of its fast detection and selectivity. So any protection that must be have the characteristics of selectivity. Selectivity is a main criteria. After the selectivity means where we using the equipment. Next one is the sensitivity. How to it sense the faults, how to it sense the overcurrents. So selectivity, sensitivity is the main criteria to design a system. So here in overcurrent protection also there is a smoothing reactors. Already we know that. What is the purpose of smoothing reactor? Smoothing reactor serves two purposes. First one is so it not allows sudden change in currents. So smoothing reactor also a overcurrent protection device. And second one is smoothing reactor eliminates harmonics.